We're going to get started with our classwork for Chapter 8. So we're looking at confidence intervals here. So let's see. We have our first problem here. You have, of the 8,500 students on a college campus randomly polled, 70% list social media as their primary means of staying up on current events. Find the best point estimate of the proportion of all students who use social media for current events news. So a point estimate, going back to chapter 7 here, is p hat, which is going to be the same as the mean. So that's going to be this 70% here. Okay, so your point estimate is 0.70. When you're asked for the point estimate, that is your p hat. Okay, then we have, of the 8,500 students on a college campus randomly polled, 70% list social media as their primary means of staying up on current events. Find the margin of error that corresponds to a 90% confidence interval. So the first thing we want to do is we want to find the z-score that is associated with a 90% confidence interval. Okay, so first of all, this is a proportion problem because you're given a percentage. So this will be a z problem. Okay, the margin of error is given by doing, in a proportion problem, z times the standard deviation of p hat. Okay, so first let's find the z of the 90% confidence interval. So if we go back to the chart in the beginning of chapter 8, move it up here, this chart right here, your 90% z value is going to be 1.645. Okay, so we get a z value of 1.645. Okay, and then we need to find the standard deviation of p hat. So the standard deviation of p hat will be given to us by the square root of p hat times q hat over n. Okay, so let's go ahead and put those values in. My p hat is going to be a 70%, which means my q hat is going to be 30%, excuse me. And then my sample size is this 8,500 right here. Okay, so let's put that in our calculator and find that value. So we're going to do the square root of 0.70 times 0.30, close the numerator, divided by 8,500, close the whole thing. We're going to get 0.0049. And let's see here. Let's make sure we did that correctly here. So 0.70 times 0.30 divided by 8,500. And then I'm going to take the square root of that. All right, so 0.00497. So then the margin of error is going to be z times this number here. So I'm going to go on my calculator and I'm going to multiply this number by my z value, 1.645. So that is going to give me an E of 0.0082. All right, number 3. We have given a sample size of 155, p hat 0.66. Find the margin of error E that corresponds to a 90% confidence interval. So this is the same thing as number 2, just with different values. So again, I'm using a z. My z in this is 90% confidence interval, so it's the same z I'm using in number 2. So I have a z of 1.645 times my standard deviation of p hat. So I'm using the same formula here. But let's see what we have here. So we have 0.66 is our p hat, which means our q hat is going to be 0.34. Those two need to add to 1. And then my sample size is 155. Okay, so I can do all of that first. Let's go ahead and do that. We have the square root of 0.66 times 0.34 over 155. Okay, we get 0.0380, and then times that by your z-value, 1.645, gives us a margin of error, 0.0626. All right, and then number 4, you're doing the same thing again, this time a 95% confidence interval. So if I look at the chart for a 95% confidence interval, that z-value is going to be 1.96. Okay, and then looks like we have actually the same values here, just a different confidence interval. So you have a p hat of 0.66, q hat of 0.34, and a sample size of 155. All right, so we'll go ahead and get that value again. So square root of 0.66 times 0.34 divided by 155, and then times 1.96. So that will give us 0.0746. Okay, so those are your margin of errors. Now in number 5, we're going to go on to a confidence interval estimate. All right, so we have a sample size of 650. We have a p hat of 0.55, a 97% confidence interval, and we want to construct a confidence interval estimate of the proportion. So the confidence interval estimate is going to be your p hat plus or minus your margin of error. Okay, and then remember the margin of error is given to you in a proportion by z times the standard deviation of p hat. And remember the standard deviation of p hat, you can just go ahead and do that, write that out here, erasing, there we go, is the square root of p hat q hat over n. Okay, so that's what we're doing for the margin of error, and then we will add and subtract it to our p hat here. Okay, and its proportion, so again, we're using z. All right, so let's first find the z value that corresponds to a 97% confidence interval. So if we look that up in our chart, that is going to be a 2.17. Okay, then we will multiply that by the square root of p hat, which is 0.55, times q hat, which would then be 0.45, over 650. So let's go ahead and do that. We have the square root of 0.55 times 0.45 divided by 650, close the square root. That'll give us 0.0195. Then multiply that by 2.17. So that's going to give us 0.0423. That's your margin of error. So then we're going to do p hat plus or minus the margin of error. So your p hat is 0.55. So we're going to go 0.55 plus or minus 0.0423. And let's see what that gives us. So 0.55 minus, we get 5077, and then plus, we get 5923. So our confidence interval estimate will be 0.5077, comma, 0.5923. So remember what that tells us is that we are 97% confident that the true population proportion lies within these values. All right, number 6, given a margin of error of 0.0045, a confidence level of 95%, and an unknown sample proportion, estimate the population proportion, find the minimum sample size required to estimate this population proportion. So this is the formula where we have the sample size. So we're looking for the correct sample size. So z squared times p hat times q hat over the margin of error squared. So here is what we know. We know that we have a 95% confidence interval, which is a z value of 1.96. So you have 1.96 squared. We have an unknown sample proportion. When your sample proportion is unknown, you're going to use 50%. Okay? So this is going to be a 0.50 for P and a 0.50 for Q. And then our margin of error is 0.0045. And then we're going to do this calculation here. So you're going to do 1.96 squared times 0.5 times 0.5. And then you're going to divide that by 0.0045 squared. So that's going to be 47,420. We always want to add round up, okay, because you want to make sure you have just enough. So you'll always round up in these. So 47,428 would be the minimum sample size to produce this margin of error. All right, and then number 7, assume that a recent statistic suggests that 35% of all persons living in a specific region are overweight. How many adults must you survey to be 99% confident that the sample percentage is within 2 percentage points of the true population percentage? So you are again looking for a sample size in a proportion. So this is the same formula here. We want a 99% confidence. So that would be a z-score of 2.575. Okay, 35% of people are overweight. That is your p hat, which means your q hat is 0.65. And then our E here, we want to be within 2 percentage points. So 2% as a decimal is 0.02. Okay, so our E is going to be 0.02. So if we plug all of these values into this formula from number 6, you're going to have 2.575 squared times 0.35 times 0.65 over 0.02 squared. Okay, so let's go ahead and do that and find this sample size. So 2.575 squared times 0.35 times 0.65, then divided by 0.02 squared. So it's going to give us 3,771.17. You will round that up to 3,772. So you would need to survey at least 3,772 people in this population, okay, to determine if that sample percentage is correct. 35% are overweight. All right, and then number 8, again, okay, we're doing the same thing here that we did in 6 and 7. Okay, now we have a margin of error 0.025, confidence level of 95%, and an unknown sample proportion. So you're doing basically the same thing as number 6, except the margin of error changes. So everything else is the same. And our margin of error has changed. I lost my pen. Where is it? There it is. Okay. So in this one, you would have 95%. That's 1.96. It's unknown, so we're going to use 0.5 and 0.5 again. And our margin of error is 0.025. All right, so we have a larger margin of error. This is a very small margin of error, so that needs a humongous sample size. This is probably going to be a bit smaller because the margin of error is a little bit more room, 2.5% as opposed to 0.45%. All right, so 1.96 squared times 0.5 times 0.5 divided by 0.025. Oh, and that should be squared there. Let me add that in on the paper. But 0.025 squared, that's going to be 1,536. We're going to round that up to 1,537. All right, how are we doing so far? Good, good, good. All right. All right, number 9. What is the correct interpretation of the 99% confidence interval of 0.75 p 0.78? Okay, so p is a proportion. We have a proportion. We have a 99% confidence interval. It's not given in context, so here you can just use what you have. I am 99% confident that the true population proportion of whatever this is contained in the interval from 0.75 to 0.78. Something along those lines. You could say I'm 99% confident that 75 to 78% of the population proportion is blah, 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 whatever it is. If we had the context, we could say it like that. I am 99% confident that the interval 0.75 to 0.78 contains the true population proportion. So something along these lines here. All right, number 10, we have a random sample of 220 female members of a health club show that they spend on average 3.5 hours per week doing physical exercise with a standard deviation of 0.75 hours. Find the margin of error that corresponds to a 90% confidence interval. So we are finding a confidence interval. We're given a sample. Okay, so the first thing we have to ask ourselves, is this a T or is this a Z? We're given a sample of 220 female members, and within that sample, we're given a mean, and we are given a standard deviation. Since the standard deviation is given within the sample of 220 people, this is T. Okay, so the sample is given within the standard of deviation is given within the sample. Okay, which means we are doing this formula here. We are doing X bar plus or minus E, where E is T times, okay, that's going to be the square root, not yet, sorry, the standard deviation over the square root of the sample size. Okay, so let's first find that T value for a 90% confidence interval with 220 female members. Now, the issue here is when on the T-chart that I gave you guys only goes up to 75. Okay, so this one you would use the infinity at the bottom of that T-chart. Let me pull over the T table real quick. Okay, so we're using this last line here, so it's going to be one of these. Now, which one is it? That's what we need to do. Which area in the right tail of the curve? So remember, when we are doing these values, okay, you think about your normal distribution curve, you have 90% confidence interval. So 90% is going to be here with half of the remaining on the left and half of the remaining on the right, which means 1 minus 0.90, which is 0.10, divided by 2, which means 0.05 is the area on either side here that you're looking up. Okay, so when I go back to this T interval here, you have 0.05. Okay, so it's the second row and the infinity. So 1.645 is our T value. Okay, so our T is 1.645. Okay, let's find our margin of error. So our margin of error, let's go ahead and find actually the sample standard deviation. So S.75, standard deviation here, over the square root of our sample size, 220. So 0.75 divided by the square root of 220 gives us 0.0506. Okay, so our margin of error is going to be 1.645 times 0.0506. So we're going to take that number, multiply it by 1.645. We get 0.0832. Okay, and then finally for the confidence interval, we will do x bar plus or minus e. So our x bar is 3.5. We will do plus or minus 0.0832. So 3.5 minus gives us 3.4168. 3.5 plus gives us 3.5836. So we'll do 2 decimal places, 3.42, 3.58. Okay, now we can also do this in our calculator. So to remember to do that in your calculator, you're going to go to Stat, over to Tests, and then you want the T interval. Enter. Make sure Stats is highlighted. Put your X bar in, so 3.5. Your sample standard deviation, which is 0.75. Sample size, 220. Confidence level, 0.90. And then calculate. And then you get 3.42, 3.58. All right, number 11. You plan to construct a confidence interval for the population mean, mu. Use the given data to determine what type of distribution will be used. So using a T or a Z distribution. So in A, you have a sample size of 12, a sample mean of 85, a sample standard deviation of 20. The population has a normal distribution. So these ones are actually a little bit tricky because you're in both of them, you're given a sample size, a sample standard deviation. But because this one has a sample size that is under 30, you're going to actually use Z here. Since this one has a sample size that is over 30, you're going to use T. Okay, now I know that seems contradictory. I'm not going to give you a problem like this on the test, but I just want you to be aware as you move forward, if you do move into an advanced statistics class, you're going to want to be aware of the sample sizes here. All right, let's do number 12. Give me just 1 second. All right, number 12, we have 165 randomly selected adults who buy books for general reading were asked how much they usually spend on books per year. The sample produced a mean of 750 and a standard deviation of 100 for such annual expenses. Determine a 99% confidence interval for the corresponding population mean. So this is Z or T. We have 165 for a sample size. We have a mean inside a sample, so a sample mean X bar of 750. We have a sample standard deviation of 100. Sample standard deviation means that I am using a T value. And then we want a 99% confidence interval. So I'm going to go ahead and do this one in our calculator, if you guys don't mind, and we'll get our interval here. So let's see here. We'll go T interval, so stat over to tests, T interval, and then we have our information here. So 750 for our X bar, sample standard deviation is 100, sample size 165, and now we are doing a 99% confidence interval. So that is going to give us 729.71, 770.29. And just looking at my notes here, it does show that if you do it by hand, you are slightly different. So if you do this one by hand, you're going to get 729.95 and 770.05. It's so close, it's within cents, like 50 cents for each of these. So don't worry about that if you do that one like that. Okay, so you're 99% confident that the cost of books, what is this? I'm 99% confident that adults spend between this amount on books every year based on the sample. All right, and then number 13, the average adult had $3,700 in credit card debt with a standard deviation of 600. Constructed 90% confidence interval for the corresponding population mean from a sample of 165 adults. So again, Z or T, let's see. We have the average adult has $3,700 in credit card debt with a standard deviation of 600. The average adult, that means that's the population. Okay, so this is a Z. All right, this is population. Okay, because it's not giving us a sample size until you're getting down here. All right, so this information is based off of a population mean and a population standard deviation. So we have a Z. Our Z will be for 90% on the chart, 1.645. And then we have a sample size, 165. Okay, so what we want to do here is we want to first find the margin of error, which will be Z times the sample standard deviation, which is going to be the population standard deviation over the square root of the sample size. So here I am doing E will equal 1.645 times, let's see here, 600 over the square root of 165. All right, so 600 over the square root of 165 gives us 46.71. And then let's go ahead and multiply that by 1.645. So that'll give us 7684. And then our confidence interval will be our mean plus or minus our margin of error. So here our mean is 3,700 plus or minus 7684. So that will give us, let's see here. So $3,623.16, $3,776.84. So you are 90% confident that the average credit card debt of Americans or average adults is between these two values. And then, of course, you can do this one in your calculator. I just wanted to do at least one example by hand. You go to Stat, Tests. Now you're going to Z interval for your test. And then make sure Stats is highlighted. Then your mean, or sorry, that's your standard deviation, which will be 600. Your X bar, your mean, 3,700. Sample size, 165. Confidence level is 90%, so 0.90. And then we have our interval here. So 3, it's only doing 1 decimal place here because it's rounding up, doesn't have enough room to give you the 2 decimal places. All right, so that is it for the Chapter 8 practice.